Hello everyone, my name is Wang. Now I'm recording homework 3 of probability and stochastic process. The first question asks us, gives us information that the probability of x equals k is this from when k starts from 1 to infinity. The sub-question 1 asks us to find the value of a so that probability of x equals k represents a probability mass function. Because the probability is a mass function, so that we can get this equation. And we replace this with the equation in the question equals 1. And then we rewrite this accumulation plus by the relative term. Then we let s equals this part when x equals it goes to infinity, and then we multiply s by 1/3. So this the right hand side should also times 1/3 for each term. We define this equation as 2, and then we let equation 1 minus equation 2, we get this. And by calculation, we can get this equation. Now let's analyze this equation. Because the speed of 1/3 to the order k decreases to 0 is faster than k increases to infinity. So the limitation of x times 1/3 to the order of k when x goes to infinity is 0. So this part is 0. And then we can get s is 9/4. A times 9/4 is 1, so a is 4/9. The second sub-question is find the expectation of x. Now we get the value of a, so we apply this value to it. The expectation of x is k times p x equals k, starting from k is 1 to infinity. And then we rewrite it. Because when k is 0, this part is 0. So we can increase the term k is k to this accumulation plus. So the range is from k starts from 0 to infinity. Now let's look at another equation. This is a popular used equation that the accumulation of p to the order of k starting from k equals 1 to infinity is 1/1 minus p. We differentiate this equation on two sides. Then we can get this part is k times k to the order of k minus 1. And this right hand side is like this. And we times each side by p. So the order to k changes to k. And here we have a p in the numerator. We differentiate on the two sides again. Then we can get the order is k2, and the right hand side becomes like this. Then we multiply each side by 4/9. Then let p equals 1/3. We obviously this equation when k equals 1/3 is what we want to find. Then we just apply 1/3 to this equation. We can get the expectation of x, which is 2. The sub-question C uses the similar reasoning. it lets us to find the expectation of x squared, which can be rewrite like this form. Yes, just like this. In sub-question B, we have got this one. And then we multiply each side by k, and then differentiate on the two sides. We can get the expectation of x squared is this formula when p equals 1/3, which the final value is 7/2. And the last question, find the conditional probability mass function when x is greater than 1, less than 10. Find the probability of x equals square. First, we have to calculate the probability of x is greater than 1 and less than 10. I separate the accumulation. We can get the value is nearly equals to 1, which means the denominator is 1, and the numerator is the value of k equals k intersects with the range of x, which is greater than 1 and less than 10, which is just the value x equals k. So the final formula is this, because the denominator is 1, so the final formula is just equals to the probability of x equals k. That's for the first question. And now let's look at question 2. X is uniform in the range -1 to 2, and y equals x squared. Sub-question A, find and draw fx. Fx, from its definition, we can rewrite it as probability of capital X less than or equals to x. So obviously when s is less than -1, fx is 0, and when x is greater than -1 and less than 2, fx is, because it's uniform, so the denominator is 2 minus 2, and the numerator is x minus 1, which is x plus 1/3. When x is greater than 2, fx is 1. And the diagram is drawn like this, according to our analysis above. The second question, find and draw fy. Okay, fy. Fy's. First, we draw the diagram of y equals x squared. When y is less than 0, or y is greater than 4, fy is 0. Y equals x squared is the gx. Yep. And for y is greater than 0 and less than 1, we let gx equals y, which has two roots. They are x equals minus and plus y square root. And based on the fundamental theorem, we could get fy equals the value of fx over the absolute value of the derivative of gx. We apply these two roots into the denominator, and then we can get the final value is 1/3 times y square root. For y is greater than 1 and less than 4, gx equals y has only one root, which is just we draw a line here from 1 to 4. It only has one root. That is x equals y square root. So fy just has one root. Here we apply it into it, and then get the final value is 1 over 6 times y square root. And by conclusion, we get the value of fy is here, and the diagram is drawn based on this discussion. For question C, find and draw capital Fy. When y is greater than 0 and less than 1, capital Y equals probability of y less than probability of capital Y is less than y. Capital Y equals capital X squared. So we apply it into it, and then we rewrite this inequality. We can get x is greater than minus y square root and is less than y square root, which by definition can be rewritten as probability of y square root minus probability of minus y square root. Then we apply the value of y square root and minus y square root into the equation of the equation of px x, and just replace the x by the two roots. Then we can get the fy is 2 over 3 times y square root. And when y is greater than 1 and less than 4, fy is the same one as this. Just this part is 0. So the final value is here. And when y is greater than 4, fy is, this part is 1 and this part is 0. So the final value is 1. And we draw the picture like this. For question D, find the expectation of y. The definition of expectation of y is y times fy, and then calculate the differentiation from minus infinity to infinity. We can, based on sub-question B, the value of fy, we could get the differentiation has a meaning only when y is greater than 0 and 1 and y is greater than 1 and 4. In the other range, fy equals 0. For this part, we get the value is 2 over 9. And this part, we get is 7 over 9. So the final value is 1. That's all. Thank you.